Hello everyone, welcome back. In this video, we're going to look at one of the most important differentiation rules, and this is called the chain rule. Now, the chain rule is used when we want to find the derivatives of the composition of functions. So the chain rule says is that if g is a differentiable function at x, and if f is a differentiable function at g of x, then the composite function, f composed with g, which is defined by f of g of x, will be differentiable at x, and its derivative will be given by the following formula. So the derivative of the composition is f prime of g of x times g prime of x. So here we can also look at writing the chain rule using Leibniz notation. So if y is equal to f of u, and u is equal to g of x, and if they are both differentiable functions, then the derivative of y with respect to x will be given as the derivative of y with respect to u times the derivative of u with respect to x. So the Leibniz notation for the chain rule will be useful for us later in the next topic. But for now, let's have a look at applying the chain rule when we're dealing with a composition of functions. So when we are using the chain rule, the most important thing to remember is to work from the outside towards the inside. What the chain rule says is that we differentiate the outer function, f, we leave the inner function unchanged, and then we multiply this by the derivative of the inner function. So let's have a look at some examples of applying the chain rule. Now notice that there are tons of examples in this section, and this is just to emphasize the importance of the chain rule, as we will be using this rule throughout the remainder of the course. So in the first example, we have y is the square root of x squared plus 1. And when we're dealing with square roots, let's rewrite it as an exponent. So this is x squared plus 1 to the power of 1/2. And so here we have a composition of functions. We have the inner function, which is x squared plus 1, and the exponent of 1/2 is our outer function. So again, the key thing to remember about the chain rule is to work from the outside towards the inside. So when we want to differentiate this function, we will look at finding the derivative of the outer function. So we have something to the power of 1/2. And we use the power rule to differentiate the outer function. And so using the chain rule, we have the power rule, which says to multiply the exponent in front. So we have 1/2. And then we leave the inner function unchanged. So that is x squared plus 1. And then by the power rule, we subtract 1 from the exponent. So 1/2 minus 1 is negative 1/2. So this is f prime evaluated at the inner function. And then now that we took care of the outer function, we need to multiply this by the derivative of the inner function. So the inner function is x squared plus 1. So its derivative is going to be 2x plus 0. So now we can simplify this. We have 1/2 times 2x. The 1/2 and the the 1/2 and the 2 will cancel. So we're left with an x times x squared plus 1 to the power of negative 1/2. In the next example, we have x cubed minus 1 squared. So again, another composition. So the inner function is x cubed minus 1. On the outside, we have the power of 2. So we apply the power rule first. So we have 2 times the inner function, which we leave unchanged, and then we subtract 1 from the exponent. So 2 minus 1 is 1, so we don't need to write the exponent of 1. And then the chain rule says to multiply by the derivative of the inner function. So the derivative of x cubed minus 1, which is 3x squared. So simplifying, this can be written as 6x squared times x cubed minus 1. In the third example, we have x to the 4 plus 3x squared minus 2 to the power of negative 5. So the x to the 4 plus 3x squared minus 2 will be our inner function. The power of negative 5 is the outer. So then the derivative, we apply the power rule. So we multiply the negative 5 in front. We leave the inner function unchanged. So that's x to the 4 plus 3x squared minus 2. We subtract 1 from the exponent. So negative 5 minus 1 is negative 6. And then we multiply by the derivative of the inner function, which is 4x cubed plus 6x. In the next example, we have sine cubed of x. Now remember that the sine cubed of x is given as the sine of x all cubed. So written in this way, the sine function is going to be the inner, and the power of 3 is the outer function. And so its derivative is going to be 3 times the sine of x squared. So we took care of the outer function. And now we multiply by the derivative of the inner. So the derivative of sine is cosine. And this can be written as 3 times sine squared of x times cos. So as you're getting more comfortable with finding derivatives, you don't need to write the step that sine cubed of x is sine of x cubed. If you can jump from the function to its derivative, then that can save you some steps. Now the next example, we have y is equal to the natural log of x squared plus 1. So here the inner function is x squared plus 1. The outer function is the natural logarithm. So we deal with the outer function first. So we need the derivative of the natural log, which is the reciprocal function. So it's going to be 1 over the inner function. Okay, so we leave the inner function unchanged, which is x squared plus 1. So that is the derivative of the outer function. And then this is multiplied using the chain rule by the derivative of the inner function. So the derivative of x squared plus 1 is 2x. So this can be written as 2x all over x squared plus 1. Now in the next example, we have cos of 8 plus x cubed. So let's identify the inner and outer functions. The 8 plus x cubed is the inner function. The outer function is the cosine. So let's deal with the cosine first. The derivative of cos is negative sine. We leave the inner function unchanged. So now that we've taken care of the derivative of the outer function, we then multiply by the derivative of the inner function. So the derivative of 8 plus x cubed is 0 plus 3x squared. In the next example, we have y is e to the power of 3x. So here we're dealing with an exponential function. And so now the inner function is going to be the exponent. So the 3x is going to be the inner function. Okay, so it's on the inside of the exponential. The outer function is the base of e. So let's deal with the outer function first. So the derivative of the natural exponential is itself. So it's e. We leave the inner function unchanged, which is 3x. So that is the derivative of the outer function. And then we multiply by the derivative of the inner function. So the derivative of 3x is going to be 3. So now in the next example, we have the root of x plus root x. So let's first rewrite these as exponents. So this is x plus x to the 1/2, and this is all raised to the power of 1/2. So now let's identify the inner and outer functions. The inner function is x plus x to the 1/2. The outer function is the exponent of 1/2. So its derivative is going to be 1/2. We leave the inner function, which is x plus x to the 1/2, unchanged. We subtract 1 from the exponent due to the power rule. So 1/2 minus 1 is negative 1/2. And then we multiply this by the derivative of the inner function. So derivative of x is 1 plus derivative of x to the 1/2. We apply the power rule, which is x 1/2 times x to the negative 1/2. In the next example, we have the sine of e to the x plus e to the sine of x. So here we will apply the chain rule at two different instances. So we apply the chain rule to the first term and the second term. So let's identify the inner and outer functions for both of these. The e to the x in the first term is the inner. The outer function will be the sine. Now in the second term, the inner function is going to be the sine of x, and the outer function is the e. And so applying the chain rule, we take the derivative of the outer function. So the derivative of sine is cos. We leave the inner function unchanged, and then we multiply by the derivative of the inner. So the derivative of e to the x is e to the x. And then we add it to, now we take the derivative of the outer function, so the e, which is itself, so that's e to the sine of x. And then by the chain rule, we multiply by the derivative of sine, which is cosine. Now letter J, we have y is equal to the natural log of sine of x. So let's identify the inner and outer. The sine is our inner function. The natural log is the outer function. And so the derivative is going to be derivative of the natural log, which is the reciprocal. So it's 1 over the sine of x. So that takes care of the natural logarithm. And then we multiply this by the derivative of the inner function, which is the cosine of x. So the derivative is the cos of x over sine of x. And we know this to be cotangent of x. So letter K, we have y is equal to 2 to the power of the sine of pi x. So for this function, we will need to apply the chain rule twice. So let's first identify the inner and the outer function. So the sine of pi x is the inner function, and the base of 2 is our outer function. So the derivative is going to be the derivative of the exponential function 2 to the power of sine of pi x, which we know to be itself, which is sine, or 2 to the sine of pi x, multiplied by the natural log of 2. So this is the derivative of the outer function. And then we multiply this by the derivative of the inner function. Now the derivative of sine of pi x, we will need to apply another chain rule where the inner function is pi x, the outer function is going to be the sine and so applying another chain rule, we have the derivative of sine, which is cosine. We leave the inner function, which is pi x, the same, and then we multiply by the derivative of the inner function, so the derivative of pi x, which is pi. So simplifying, we have pi times the natural log of 2 times cos of pi x times 2 to the sine of pi x. In the next example, we have 2x minus 3 to the 4 times x squared plus x plus 1 to the power of 5. So here we have the product of two functions, and so we will need to apply the product rule. And as we apply the product rule, we will also need to apply the chain rule. So we'll call 2x minus 3 to the power of 4 as f, and x squared plus x plus 1 to the power of 5 as our g. So the product rule says that we differentiate f. So the derivative of f, we use the chain rule. So the outer function is the power of 4. So we multiply the 4 in front. We will leave the inner function unchanged, so 2x minus 3. We subtract 1 from the exponent, which is 3, and then we multiply by the derivative of the inner function. So the derivative of 2x minus 3 is 2. So this is f prime. We multiply this by g, which is x squared plus x plus 1 to the power of 5. And then we add this to f, which is 2x minus 3 to the power of 4. And then we differentiate g. So using another chain rule, we have 5 times x squared plus x plus 1 to the power of 4 multiplied by the derivative of the inner function. So the derivative of x squared plus x plus 1, which is 2x plus 1. For letter n, we have y is x squared plus 1 over x squared minus 1 to the power of 3. And so here we will apply the chain rule. And as we apply the chain rule, we will also need to use the quotient rule. So the inner function is the x squared plus 1 over x squared minus 1. The outer function is the exponent of 3. So the derivative of the outer function using the power rule is 3 times the inner function to the power of 2, and then we multiply this by the derivative of the inner function. So the derivative of the inner function, we use the quotient rule. So we have 2x times x squared minus 1 minus x squared minus 1 times 2x. And this is all divided by x squared minus 1 squared. Letter O, we have y is e to the power of x times the sine of 2x. So for this function, we will apply the chain rule. And as we apply the chain rule, we will also need the product rule. And as we apply the product rule, we will need another chain rule. So the outer function is the exponential. The inner function is going to be x times the sine of 2x. So the derivative of the outer function, which is the exponential, will be itself. So that is e to the x times sine of 2x. And then we multiply this by the derivative of the inner function. So here we apply the product rule. So we'll call x as our f. The sine of 2x is our g. So the product rule gives us 1 times the sine of 2x plus x times the derivative of g. And to find the derivative of g, we apply another chain rule. So the outer function is sine. The inner function is 2x. So we'll start with the outer, which is cos. We leave the inner the same. And then we multiply by the derivative of the inner. So derivative of 2x is 2. And so the derivative is e to the x times the sine of 2x times the sine of 2x plus 2x cos of 2x. For letter P, we have the natural log of x times e to the negative 2x. So here we apply the chain rule with product rule and another chain rule. So the inner function is x times e to the negative 2x, and our outer function is the natural log. And so the derivative is 1 over x times e to the negative 2x. So that takes care of the outer function. And now the inner function, we need to apply a product rule. So we will call x as f, and e to the negative 2x is our g. So this will be 1 times e to the negative 2x plus x. And then we apply the chain rule for the derivative of g, which is e to the negative 2x times negative 2. And so simplifying, we have e to the negative 2x plus or minus negative 2x times e to the negative 2x all over x times e to the negative 2x. So here we can simplify further. We can factor out e to the negative 2x in the numerator, which leaves us with 1 minus 2x, and that's all over x times e to the negative 2x. Now the exponentials can cancel, so we're left with 1 minus 2x all over x. So for letter Q, we have y is the cosine of 1 minus e to the 2x over 1 plus e to the 2x. So here we apply the chain rule. The inner function is 1 minus e to the 2x over 1 plus e to the 2x. And on the outside, we have the cosine. So the derivative of cosine is negative sine, leaving the inner function unchanged. And then we multiply this by the derivative of the inner function. And to find the derivative of the inner function, we use the quotient rule. So the derivative of 1 minus e to the 2x is negative e to the 2x times 2. This is multiplied by 1 plus e to the 2x. We then subtract 1 minus e to the 2x, and then we multiply by the derivative of 1 plus e to the 2x, which is e to the 2x times 2. And so this is all divided by 1 plus e to the 2x squared. So if we look in the square brackets, we have a common factor of e to the 2x and a 2. And if we want, we can also take out the negative as well. And so if we factor out all of these terms, you will get 2 times e to the 2x. So we had a negative originally, and we factor out a negative, which will make it positive. Then it's sine of 1 minus e to the 2x over 1 plus e to the 2x. And then this is multiplied by 1 plus e to the 2x plus 1 minus e to the 2x. And this is all over 1 plus e to the 2x squared. And we can simplify in the brackets. So we have e to the 2x minus e to the 2x, which can cancel. And so we're left with the 2 in the numerator. And we can multiply that 2 in front, giving us 4 e to the 2x times the sine of 1 minus e to the 2x all over 1 plus e to the 2x. And this is divided by 1 plus, e to the 2x all squared. In the last example, we have the natural log of x squared times cos of x. So here we apply the product rule. So the natural log of x squared is our f. The cosine of x is our g. So the derivative is f prime. So here we apply the chain rule. So the outer function is the power of 2. The inner function is the natural log of x. So the derivative is 2 times the natural log of x to the power of 1. And then we multiply this by the derivative of the natural log, which is 1 over x, We multiply this by g, and then we add this to f, so the natural log of x squared, times the derivative of g, which is negative sine. So this can be written as 2 over x times the natural log of x cosine of x minus the natural log of x squared times the sine of x.